Welcome to part 8 of programming Slither.io in Python, and I'm really excited for this video just because this video finally goes over making AI, which is going to be, after this, most of the work for this series is already done. After that comes combat, but really there's a lot planned for today, and I'm excited to get started. We're going to make AI because as it stands, and as we left off, the player is just one lonely snake on the screen, and we want to get a lot more other snakes to join the fun. So that's what we're going to work on today. But before we go to start coding AI, and as you can probably guess, I plan on making an AI class, we need to clean up the player class a bit. So one of the most crucial parts of the player is the direction he moves. He always moves in the direction of the mouse. But notice we don't really have a direction variable. We just have this distVec, which if you recall from a previous video, the distVec is just the distance vector, and it really is not even distance vector. I should call it direction vector. It's a direction vector between where on the screen the mouse is and where the player is, using that simple formula, target minus your position. So this is the direction that the player is moving, and then in this line of code we shrink it down so that it has a length of 1, and we can multiply it by any speed we want. But I really want to store this as a private variable because, as we're going to see later on, the AI are also going to have a direction variable, and this is just cleaner than just having this random variable here. So I'm going to create self.direction, and it's going to be an empty list. And now distVec, every single time it appears, I'm going to replace it with self.direction. And so I'm going to copy and paste and try to get all of these, but when I practiced recording this video, I missed a few of them, so let's see if I can actually get them all this time. Every distVec reference needs to be replaced with self.direction, and for some reason I accidentally copied it with a space. Same thing inside of this if statement. That's another thing I missed when I recorded this the first time. They also have to be edited. But now with that, it should be working. Let me go ahead and run it, and we have changed nothing float object not subscriptable. What did I do here? Oh, I accidentally pasted an extra subscript. Copied too much with that. There we go. So now we've changed nothing except for the fact that the player now has his direction stored in a variable, which is how it should have been from the beginning, but I just didn't think of it. And one more thing we're going to change. This update function is getting really messy. Up here, we calculate where the player moves. Here, we move the player. Here, we determine if a new segment needs to be added. And in this for loop, all the segments are updated to follow either the player or the next segment in line. And we're going to split this into parts. For now, I'm just going to add one extra part. I'm going to put all this mouse direction stuff inside of its own function, and I'm going to call it calculate direction. Define calculate direction, and I'm going to paste all that code from mouse position up until before we add to the position. So all this here, I'm going to cut, put it in calculate direction. And of course, we passed in the window dimensions in the update function so that we could convert the mouse screen position to a world position. And if you're unclear about that math, you can rewatch that video. But we need to also add it here. So when dims, so now it's referenced here. And now I'm going to add a call to that function at the beginning. Calculate direction with when dims. And now I'm going to test it once again, and hopefully nothing's changed. And once again, I made a mistake. And what's funny is I made the same mistake when I was practicing the tutorial, and I just did it again. I forgot the self. I am calling a member function inside the class itself, so I need self. And now, once again, we still have not changed anything with our output, but our code is getting much better. This is a very clear line of code here. and it's clear as to what its function is. So this is very good. The next thing we're going to do, now that the player is all cleaned up, we're going to do more inheritance. And for that, I have my paint example again. So the first time I talked about inheritance, it was when we were coding the object class, because I noticed that every single object had self.rect, image, texture, a draw function, and all that was just getting repeated. But and so we made an orb or an object class for that. This time we're going to make a snake class, because if we look at the player, every snake is going to have speed. Every snake is going to have previous score. Every snake is going to have score, segments, direction. And also all this logic here of only adding a segment once you increment your score by a certain amount, all the snakes, AI and players, are going to have that in common. So if I just start coding up an AI class right now and repeat all this, I'm really wasting my time. So here's how our class is going to work. We're going to have an AI class, or sorry, a snake class, who will have the direction, segments variable, and well, we had a whole bunch of stuff here. What else did we have? We had speed, score. So the snake is going to have all these commonalities, but we're going to, from the snake class, create a child class, player, and the player is going to have his own calculate direction function. The AI is going to have its own calculate direction. But they're both getting all these repeated variables from Snake, and our code is much more reusable this way. Our code is much better this way. Now you might ask, wait a minute, aren't these repeated? Why can't I just put calculate direction here inside of the Snake class? I can't even type and think at the same time. The answer is because the calculate direction functions they're the same name, but they're doing two vastly different things. The player's calculate function follows the mouse. It sets the direction variable to the mouse, or points it towards the mouse. The AI, as we're going to see later in this video, the AI simply finds the nearest orb. So the direction that the AI will follow is just the nearest orb. So these are the same named functions, but their logic is much different, which is why we're going to keep them inside of their respective classes here. But now, let's create the snake class. Right-click on your project name, Python file, snake.py. And inside of here, I'm going to do a really professional coding move, and I'm just going to copy everything inside of player and paste it in snake. Now, I'm going to rename a lot of stuff. So snake. Snake is still going to inherit from object, by the way. So it's like we have another layer of inheritance on top of that. We still have the object class, which has rect and image and texture, and snake inherits from that. So we're taking this inheritance thing to a whole new level. So the snake inherits from object. All this stuff here stays the same. Now with the update function for snake, we're going to get rid of this because the calculate direction is not going to be its job. And I'm going to leave all this here. So where we add, this is where we move the snake. That's going to stay the same. Where we calculate the segments and when they need to be added, that stays the same. And updating the segments, that remains the same. Draw is the same. And calculate direction, we delete. So now we have our snake class here. I'm going to go to player now and modify it to where it no longer inherits from object, it now inherits from snake. And that is entirely legal to do because player is still going to get his essential rect and texture from object because snake is inheriting from object. So you can do it two ways like that. I'm going to delete all these common variables. I'm going to get rid of all of this stuff that's already in the snake class. I'm going to get rid of the draw function. And now our player class is much nicer. All our common stuff is stored away, which is really good. Now we're going to do something different here. So right now, our calculate direction, we need to call this function, which is the player's update. So we need to call the player's update function, but we also need to call the snake's update function, because the snake's update moves the snake and then calculates all the stuff which I just summarized a second ago. But we need both of these. So after we calculate the player's direction, I'm going to call the snake's update function. And you can do that. Even though the snake has its own update here, you can call a function and go upwards if you want to think of it like that. Just like we did with the constructor, I'm going to type super dot update like that. And now that I think about it, the update function for the snake does not need window dimensions. That was solely for direction calculation for the mouse. So windims, we can take that out, do not need it. So super refers to the snake, the parent of player, which I probably should specify. This should be snake, not object. We are now inheriting from snake. Super is the snake, and we are calling its update. So the player will calculate its own direction, but then here it hands off all the rest of the work to snake. And that's how we're going to be executing this. Hopefully I did not make a mistake. It's very likely I did. Oh wow, look at that. And I think this is the longest I've recorded without having to break and fix a bug. So now we are still at the exact same output as before, but now we have our snake class, which is going to really help us out when we do our AI class. All right, now let's actually add that AI class. So I'm going to add the file for the AI, and I'm just going to call it ai.py. And inside of here, we're going to import the snake. So from snake, import snake. And I'm going to create the AI class AI. And it's going to inherit from the snake just like the player is. Now for the AI's constructor, I think it's also going to be exactly the same as the player. I have to make it to where anything that the snake constructor wants, the AI constructor can provide. That's why all the constructors have been the same here. We have the exact same arguments here and here. Same thing with snake and orb. It's been largely the same. That's because whatever one constructor on the level above asks for, you got to provide. So with the AI, I'm just going to give it x, y, width, height, file path, exact same thing as we've been doing. And then I'm going to call super.init, which is the snake's constructor, and pass in x, y, width, height, file path. Now, this AI is also going to need his own update function. And this update function is also going to need to calculate the direction. It's going to be almost the same as player. All player does is calculate the direction he needs to move, and then he updates using the snake's logic here. We're going to do the same thing. So back in AI, and if I'm going to keep moving back and forth, I better move the file. We're going to create a calculate direction function for the AI. And for now, what we want is the AI to find the nearest orb, but that's not important for now. For now, we just need to get AI. So I'm just going to say that the self.direction, which is a variable which is now stored in snake, the direction is just going to be the down vector, like that. Because, and remember it's +1, because in Pygame, as y goes down, it gets bigger. So this is a really bad calculate direction function. All it's going to do is set the direction to down, But if we can get this AI working at least with this, then we'll be able to add the logic later where it follows every orb. So in the update function, we'll calculate the direction, and I need to put self. I almost did it again. Self.calculate direction. And I'm going to call the snakes constructor here. Or sorry, the snakes update function, like that. So just like this, the AI class is already set up. And again, this is why inheritance is really important. If we chose not to do inheritance, then all of this stuff with the segments, we would have had to type twice. And of all the code in this whole project, I think this code here is the ugliest. And I do not want to do it twice. But now let's go to main game and actually give some AI to the game. So in the main game constructor, we have player orbs. I'm going to add right below that self.ai as an empty list. And we're going to initialize it almost the same way as we did with the orbs. I'm going to create a constant, num AI, and I just want one for now. I can worry about adding more later. So in the init function, we have this for loop to create the number of orbs. Now I need a for loop to create the AI, num AI. And most of this, again, most of this is going to be the same. This is one advantage of using a main game class. It's really clear cut where all of this stuff needs to go since we cleanly defined an init function and all that stuff. So let me continue. The AI is going to spawn randomly anywhere on the screen. So 0, self.windims 0. And at the end of this video, we're going to fix that because it looks really bad having all the orbs spawn on the screen. We'll fix that later. But for now, we're just going to simplify it. And the only place that the orbs and AI can spawn is on the screen. Set the Y 0, self.windims 1. This is the exact same as what we did for the orbs. Now for the size of the AI, since again that's what our AI constructor wants, his position, and then his width and height and file, I'm going to make that the same as the player because I don't want the AI to be any bigger or smaller than the player. So for now, I'm going to skip over the size variable, and I'm just going to create the new AI right here. New AI is equal to AI, which I do need to import that now, so from AI, import AI. So I'm going to create a new AI with random X, random Y, and we're going to use the same size as the player. Start width, start height, like that. And then I'm going to hard code the file path to body red.png like I believe I have been doing. I could put this into its own texture. Have I already? Player texture, I did put that in a variable. I'm just going to use that here. So player texture. It's going to start with the same texture as the player, same dimensions as the player. So now we created the AI. Let's actually update them. So after we update the orbs, we're going to use another for loop, for, and I don't want to say AI in self.ai. I don't really like that. I'm going to say for snake in self.ai, snake.update, and now we're going to render all the new snakes. So after we render the orbs, for snake in self.ai, snake.draw, and it has the same thing as all our draw functions. It needs a window and it needs a camera, like that. So hopefully I did not make a mistake, and when I run this, we should have one dot of an AI moving straight down. I don't see any AI. Let me run it again. The thing is, he's moving straight down as soon as he spawns, and he has the exact same speed as the player, since their speeds were initialized with 10. So I'm going to do that right now. I'm going to I'm going to make the AI a little slower. Self.speed is equal to 5. Now, this is not a new variable. Speed is already inside of Snake. I'm just resetting it here. You still do need to add self. And right now, I don't see any AI on the screen. I believe what I did wrong is, yep, that would make sense. I never actually added this new AI to the list of AI here. So you got to do that. Otherwise, none of our for loops run. Self.ai.append new AI. And now hopefully we'll get an AI running around at the bottom of the screen. I still don't have it. I'm going to run it one more time. There he is. So we have an AI that's moving straight down at the very bottom, just moving straight down, and I missed him. You miss him if you don't catch it pretty fast, but now let's give him a better calculate direction. So right now, that's really good. Let's add more AI, maybe 10. And now we have 10 AI, all moving down. So now let's give them a better, I hate to say AI again, but give them better AI. And now that we have the AI, we can change this calculate direction function. For simplicity, just to add them to the game, I kept it as them moving straight down. But now, we're going to do what I mentioned at the beginning of the video. All the new AI are simply going to find the nearest orb and try to eat it. So what we're going to need is to pass in orbs to this function and also update since it calls the calculate direction function. And before I forget, I'm going to go to main.game.py, and when I update the AI, I'm going to give it the orbs. So right here where we update the AI, self.orbs. We need to do that because the AI needs to be able to know where the orbs are, have access to this data so it can track the nearest orb. So I'm going to create a closest orb variable, closest orb, and I'm just going to set it to the very first orb in the list by default. I'm going to set a closest distance variable, and I'm going to set it to a really big number. And here's what we're going to do. We're going to use a for loop to go through every single orb, and we're going to calculate the distance between the AI and that orb. And we're going to store whichever distance is closest in this variable. And by the time we're done, whatever orb we found to be closest, we're going to store in this variable. So I'm going to create the for loop. For orb in orbs. The first thing we need to do, if we want to find the nearest orb, is we need to get the direction vector between them. And here's a little review from, this was from when I was recording earlier. A little review. If this is the AI and this is the orb, if I want the direction between them, like this, then I simply calculate that direction vector with the formula direction is equal to target minus start position. But in this case, it's actually going to be direction is equal to orb position minus the AI position. So using this logic, we're going to get the direction. Then we need to see if it's closer than our closest orb distance, but we'll worry about that in a second. So let's get the direction. The direction is equal to a list which will just have orb.rect.x minus self.rect.x, orb.rect.y minus self.rect.y. And now we need to see, this is the direction, but we need to see how close they actually are. And for that, we're going to use the length formula for a vector. And if you recall, once again, from the last video or a previous video, the length of this direction vector, or in other words, the distance, is just equal to the square root of the direction dot x squared plus the direction dot y squared. That's the formula. So you calculate what this actual direction is using this formula here, but then you determine how close these two objects are using the distance formula here. The square root of this direction squared, x squared, y squared, square root of that. I think you get the picture. So now let's get distance is equal to, and I'm going to create the square root part first. And now, inside of here, direction dot x squared. Oh, no. Direction 0 squared plus direction 1 squared. That is the distance. So here's what we'll do now. If the distance is any less than the closest distance, if this distance is any less than the closest distance, which since we set it to a big number, this most likely will happen, then our new closest orb is equal to this current orb that we're looking at, the one we're iterating through in the for loop. The closest orb is equal to this orb, and now our closest distance is equal to this distance. And you can see how as this for loop runs, this is going to give us the closest orb, because once we're, say, in the third orb, if that orb's distance is any smaller, then the closest orb is going to be equal to that one. We're going to reset the distance here. This algorithm will give you the closest orb. And now, after the for loop runs and we have our closest orb, we now have a target, and now we can give a direction or calculate a direction to that target. So I'm going to say the direction, the one we're ultimately going to use for the AI, is going to be, and I'm just going to, oh, I can't copy it. Closest orb dot rect dot x minus self dot rect dot x closest orb. I keep messing up the word closest for some reason. Closest orb dot rect dot y minus self dot rect dot y. So now we have the direction, and like we did with the mouse position tutorial, once we calculate the direction between our AI and the closest orb, we need to take this vector and shrink it down to a length of 1 by dividing the direction x and y by the length. So the direction, we're going to shrink by saying that we're going to say the direction dot x, we're going to divide it by the distance, and the direction y, we're going to divide it by the distance, or the length. I'm using length and distance interchangeably here, just the length or the distance of this direction here. So we have our direction. Now let's get how long it is. The length is equal to, we're going to use the distance formula again. I can just copy all this here since we use the same direction name. That's how long this direction is. And now, direction 0, we're going to divide it by that length we just calculated. Direction 1, which is y, divided by the length we just calculated. And now this is not where we do self.rect.x plus equals direction times speed, because remember, we already do that in the snake. This code here in the snake's update function, this will move the snake. In the AI, we're not worried about moving it. We just want to calculate the direction. So I'm going to say self.direction is equal to direction. And now I'm going to run this program, and I believe it's going to crash immediately, which is just fine because I am expecting it. And it does crash for exactly the reason that I thought it would. The direction we get a 0 division error. Here's what happened. So, believe it or not, our code actually worked. The AI was calculating the nearest orb, and he found the closest orb, so he moved towards it. But right now, if you look at orb, there's no code that says to delete the orb once the AI touches it. So what happens is if I have my orb here, and I would like my circle select, if I have my circle, my orb, and then my AI here, as the AI moves closer and closer, right here it should delete since they're touching, but it doesn't. So instead it keeps moving closer until right here. Their positions are the exact same. What does that do to our direction? Well, our direction is equal to a orb position minus AI position. But if these two are the same, then direction is 0. And then when we do the length calculation, the square root of 0 squared plus 0 squared, we still get 0. So length is equal to 0. And right here, when the step where we take our direction and shrink it down, well, it's already 0, so we can't shrink it. We try to divide it by 0 right here, and we get a float division by 0. So there's two things we could do. We can make sure that we never actually divide by 0 by saying if the length is equal to 0, we're just going to return like that. And we're going to prevent this from happening. And that kind of works. So notice what happens. Oh, I'm going to see if I can... My player's too fast. I don't like that. I'm going to make the player a little slower. I'm going to make the default snake speed at 7. So let me find wherever the AI is. Notice how he's jittery. It's because he's on top of the orb that he considers to be the closest, and he's as close as he can get. And he's constantly recalculating his position, trying to get closer, but he really can't. Watch, as soon as I eat the orb, he's going to find the next closest. And he's going to find the next closest. But now, a real fix is to actually have it where the AI can eat the orbs himself. So in the orb update function, this is where we say we return true if the orb needs to delete, and we return false if it's okay. Here we see if the orb is actually touching the player. I'm going to also add the AI, and we're going to use a for loop and see if the orb is touching any of the AI. For snake in AI, if self.rect.collideRect snake.rect, then we're going to, we do got to add to the snake score, otherwise he won't get new segments, dot score plus equals score increment, which is just the amount of points you get each time you touch the orb. We defined it here. And then return true to delete this orb when we're done. And before I forget, we created a new parameter, so now in the main game we actually need to pass that in. Here is where we update the orb. So we pass in player, now we'll pass in the AI. And now we shouldn't get that AI jittery thing. The AI should be moving. And look at that. He is calculating where the nearest orbs are, and because all of our segment code worked perfectly from the player straight to the AI, he is now getting much longer. And by this point, we'd have a clear winner. Oh, and we get an error here. Notice how the error only happened as soon as there were no orbs left. That's because we, right here, where is it, the AI, where we're trying to find the nearest orb, we set it to the first orb in the list. Well, I'm going to run that again so you can see it. So the AI and myself, we're going through all the orbs. We're going to eat them all. The AI's movement is so much more precise than mine. And right there, as it ate the last orb, it crashed because the orbs list was empty. And then when I said orb 0, the closest orb, we're going to set it by default to the first one in the list. Well, there is no first one. So all this logic below it just does not work. It crashes. So what we're going to do is say if the length of orbs is equal to 0. So if there are no orbs left, then we're just going to return. So we're going to exit this function early if 1, our length, our direction vector is ever 0. And we're also going to return early if the orbs are ever, or if they ever run out. But as it stands, we've already made a lot of progress. I mean, the AI, his movement is really janky, but it's looking really good, especially with the segments. And I'm going to see what happens when he eats the last bit of orbs. And now no crash. He's just stuck at whatever direction he was at last, since he's now never going to calculate a new direction. But that worked exactly the way we wanted. And this tutorial is almost over. This is probably going to be another really long one once I finish editing it. But that is okay. We got a lot of stuff done in this tutorial. The last thing I'm going to do in this tutorial is fix this really ugly all the orbs only spawning on the screen and all the AI only spawning on the screen. And that's because in the main game, where is it? The main game, right here, we're telling the orbs to only spawn between 0 and the width of the screen, and 0 and the height of the screen, same with the AI. What we should be doing is something like this. If we have our screen here, we should allow the orb to spawn anywhere between a certain length beyond that screen here. So like, I'll do it like this. I'm going to allow the orbs to spawn anywhere from the screen to 3 times the length of the screen. So imagine this area as if this is the screen width, this area right here, well then this is screen width times 3. So I'm going to let the orbs spawn anywhere from a negative screen width times 3 to a positive screen width times 3. And the same thing with height. If this is the height of the screen here, screen height, then this is going to be the screen height times 3. I hope that made sense. What we're doing is expanding where all our stuff can spawn, because right now the stuff can only spawn in this tiny box. We're going to make the box bigger by doing this. I'm going to copy this, and we'll start with the orbs. The orbs can spawn between a negative screen width times 3 and a positive screen width times 3. And I'm going to do the exact same thing with the Y. I'm just going to change the subscripts from 0 to 1. And I'm going to do the exact same thing with the AI. Change these from 0 to 1. And all we did was say, well, now you can spawn outside of that given area. You can spawn between the negative, this is negative screen width times 3, this is positive screen width times 3, negative screen height times 3, positive screen height times 3, like that. And so I hope that explanation didn't confuse you. When I run it, we're going to get something that looks a lot more like Slither.io. Like, this looks really good. This is the way you actually play the game. There's orbs everywhere, and you're just hunting them down. I'm going to see if I can find that AI. I have no clue where he is. But let's add more. So I'm going to go to main game. I'm going to add more AI. And by this point, the tutorial is basically done. So if you want to log off now, you can. I'm just going to stress test it. I'm going to create 10 AI, see how that runs. And we got 1 AI here. Let's also add more orbs so that there's more food to go around. I'm going to double the orbs from 200 to 400. And I'm still not quite happy. Well, I feel like the orbs are good here. We have plenty of orbs, but we have not enough AI. I'm not finding enough of them. So how many AI can I add? Can I add 20? All right, 20 still seems to run okay. I'm still not running into any AI, but that's still working. Now I'm gonna stress test it, see how many AI we can process. So I'm gonna change it to 100, and it's probably gonna get, yeah, it's laggy. So I see AI immediately, but it's really laggy, and it goes back to normal. The reason this is happening is because there's just a lot of checking. Every single AI loops through every single orb, and every single orb loops through every AI. So obviously, the more AI there are, the laggier our game will get. So 100's a bit too much, but I did like 20. So with that, that concludes the video on making AI in Slither.io. Good job for watching all the way up to this point. Hopefully somebody did watch all the way up to this point. And I'll see you next time. The next topic will probably be combat, since right now I can't actually kill any snakes and I can't eat them when I'm done. So we're going to fix that for next time. But thank you for watching.